Here. So in the last class, just we had an introductory session, right? What is big data and why Hadoop drawbacks with the current databases? Yes, big data like huge volumes of data. So currently we have got databases for storing the data like Oracle, MySQL, DB2, SQL Server, and we have got some special. Just I'll take 2 minutes what we have discussed in the last session. Specialized databases like Netezza, Vertica, and Teradata used for data warehouse purpose. But these databases and specialized databases, they can handle data up to some certain extent, right? Beyond that, they cannot support, right? So we have got, so as a solution to all the storage level problems and processing level problems, we have got a framework like Hadoop. Hadoop is mainly meant for two things. Generally, any technology used either for storage or for processing. They're used either for storage or processing, but Hadoop is used for both storage and processing. Yes, meant for storage, and second meant for processing. It is meant for both storage and processing. Hadoop is meant for both storing data and processing data. We talk about like C, C++, Java, .NET, all meant for processing. Oracle, MySQL, DB2, SQL Server, all meant for storage. But Hadoop performs both storage and processing. For storage, it doesn't use any databases because databases has got a lot of drawbacks as compared with this, right? So Hadoop is going with a special kind of file system. It's going with a special kind of file system called as Hadoop distributed file system. And for processing, it is not going with any, for processing, it is not going with any current technology, right? Yes, it is going with an execution model called as MapReduce, and currently we are using Spark. Spark, very high speed processing technology, processing huge data in quick time. All right, yes. So for storage HDFS and for processing MapReduce or Spark. Yes, drawbacks with the current databases. Drawbacks with the current databases. What limit? Okay. So if it, before I go with the drawbacks with the databases, you may ask why if Hadoop is there for storing and processing, what is the use of the current processing technologies and storage technologies? Already Hadoop can perform both storage and processing. Why again this storage and processing technologies? You need to clearly understand, right? Hadoop is for batch applications. Hadoop is for batch applications. Sorry. Hadoop is meant for batch application. Hadoop is meant for batch applications. Hadoop is meant for batch applications. So there are two types of application. What do you mean by batch application? There are two types of applications. There are two types of applications. The first one, online applications. Second is like batch applications. So what is the difference between these two? Online applications and batch applications. Hadoop is not for online applications. Hadoop is meant for batch applications. Online applications, user interactive applications, user interactive applications, user interactive applications. Here user gives the input. User interactive applications, here user gives the input. User gives the input. Example, booking a movie ticket. Booking a movie ticket. Making an online transaction. Making an online transaction. Booking a movie ticket, making an online transaction, right? So here compulsory, yeah, the user need to use the input, like source account and destination account. User has to provide that how much amount to be forwarded and what is the source account, what is the destination account. User interacts. But batch application, user non-interactive applications. User non-interactive applications. User non-interactive applications, right? So Hadoop is meant for this user non-interactive applications. Here, user is nowhere required. User is nowhere required. User is nowhere required. Here, example, railway ticketing PNR status. Railway ticketing PNR status, currently our status is 200. After 1 hour, it is 150. Tomorrow morning, it is 100. Tomorrow evening, it got confirmed. Tomorrow evening, it got confirmed, right? Yes. Railway ticketing PNR status. So this is happening. And here, user is nowhere required. Here, everything happening in the background. Most of these banking applications and financial applications are batch applications, and also like generating credit card statements for millions of customers. Credit card statements for millions of customers. For millions of customers. Generating credit card statements for millions of customers. Railway ticketing PNR status. That's generating credit card statements for millions of customers. Okay. So understood, right? Online applications, batch applications. Hadoop is meant for batch application, not for online applications. So batch applications, user non-interactive applications. And here, drawbacks with the current databases. Why databases are not used for storing Hadoop's data? Drawbacks with the current databases. First thing is limited storage. Most of the databases very less storage, right? Limited storage or less storage. No parallel processing in most of the databases. No parallel processing in most of the databases. And as volume increasing, speed decreases. Here, see that queries, right? For example, total amount from sales 1, 10 records. Total amount from sales to 10 lakh records. Total amount from sales 3, 10 crore records. Here, as volume increasing from query to query, as the volume increasing, speed decreasing, right? The same way, if complexity increasing, also speed is decreasing here. Total amount from sales 1 lakh records. Average amount from sales 1 lakh records. Standard deviation of amount 1 lakh records. But here, query to query, which query executes faster? Again, the first query. Second query is a two-step process. First sum, next average to be calculated. complexity increases, speed decreases. If complexity increases, speed decreases. So here average amount is a two-step process as compared with the first query. Second step takes a lot of time, right? And select standard deviation of amount from sales one. So standard deviation of amount from sales one means as compared to the first query and second query, the third query standard deviation takes a lot of internal processing. It takes a lot of internal processing, right? Databases can handle only structured data. They can handle only structured data. They cannot handle unstructured or semi-structured data. They can handle databases can handle only structured data. They cannot handle unstructured or semi-structured data. Yes, these are the major drawbacks, right? Yes. Limited storage, no parallel processing. As volume increases, as speed decreases. Total amount from sales one, total amount from sales two, total amount from sales three. Here 10 records, here 10 lakh records, 10 crore records, right? So volume increases, speed decreasing. Complexity increases, speed decreases, can handle only structured data. And coming to the Hadoop advantages. Yes, before I go to the Hadoop advantages, you need to know something about the Hadoop architecture. Hadoop doesn't follow client server architecture. It won't follow client server architecture. It won't follow client server architecture. It won't follow request response architecture. If you are giving request, giving response, that kind of architecture is not for Hadoop. Hadoop follows master slave architecture. Hadoop follows master slave architecture. Master slave architecture. Hadoop follows master slave architecture. Single master, multiple slave. In this way, just observe this diagram, right? So single master and multiple slaves architecture. So how Hadoop is able to accommodate unlimited data? How it is going to store unlimited data? Why not the other databases? Huge data storage, unlimited data storage, and huge data processing is possible in Hadoop. Single master and multiple slaves. Slave 1, slave 2, so on, slave n. This is the master. Slave 1, slave 2, and slave 3. f1.txt. f1.txt. This f1.txt is divided into smaller parts. F1.txt, it is divided into smaller parts. See, Hadoop masters single master, multiple slaves. This we call it as a cluster. Single master, multiple slaves. This we call it as a cluster. B1, B2, B3. A file is divided. So here each system 1 TB. Single master and multiple slaves. So here each system of 1 TB, 1 TB, 1 TB, 1 TB and 1 TB. But here my file is of 2 TB. This file cannot be accommodated in any of this slave because this 2 TB file cannot be stored in any of this S1 or S2 or S3. So it will be divided into smaller parts. Smaller parts we call as blocks. So smaller parts, each one is stored in one system. Each one is stored in one system. File is divided into smaller parts. Each one is stored in one system and processed parallelly. So here two advantages we can see. Huge data sets or huge data objects can be stored, can be accommodated, even it's 2 TB or 3 TB or petabytes. So still if you have got some 40 systems, your data is divided into partitions and those are distributed across multiple systems and processed by multiple systems parallelly. You no need to take care about all this. It automatically takes care. Just you need to give what is the size of each block. That's the what is the size of each block that you need to give. Automatically divides and stores across. Two advantages: distributed storage and parallel processing. So your data is stored across multiple systems. Data is processed by multiple systems parallelly. B1 stored here, B2 here, B3 here. Executing the B1, nothing but a T1 task. Executing this B2, nothing but a T2 task. Executing this B3 is nothing but T3 task. T1 task assigned to system 1, T2 task executing this B2 is nothing but is assigned to system 2, T3 task is assigned to system 3. Means master is assigning a task to the slave. So slaves has to execute the tasks. It everything taken care by framework itself. You don't need to perform any of this. So master, what do you mean by a cluster? What do you mean by Hadoop cluster? What do you mean by a cluster? Group of nodes. Group of nodes. What do you mean by nodes? Nodes nothing but CPUs. Connected in a network. Connected in a network. Group of nodes, CPUs connected in a network. There are two types of nodes. There are two types of nodes. Master node, slave node. First is master node and second is like slave node. Master node, slave node. Master node responsibilities. Master node responsibilities. Master node responsibilities. Task assignment. Second is load balancing. Task assignment, load balancing. Master node responsibility, task assignment, load balancing. So assigning tasks to the slaves, what are the tasks assigned should be equally assigned to all the slaves. And third is fault tolerance. Fault tolerance means, observe, if multiple tasks, T1, T2, T3 assigned to multiple slaves, see multiple tasks T1, T2, T3 assigned to multiple slaves. So when they're executing parallelly, suddenly if any one system is down, then the task of it has to be assigned to any of the other slave. That is called fault tolerance. So later I discuss in brief about it. And health monitoring. Next is like health monitoring. Health monitoring. Master node responsibilities, task assignment, load balancing, fault tolerance, health monitoring. Yes. Slave node responsibilities. Data stored in the slaves, data processed in the slaves. Slave node responsibility, data storage and data processing. Data processing. Data storage and data processing, right? Yes. So later I discuss in brief about this architecture, storage architecture and processing architecture. Storage architectural components and processing architectural components. Hadoop advantages, unlimited data storage. Unlimited data storage because of horizontally unlimited scalability, because of horizontally unlimited scalability. Horizontally unlimited scalability. Very high speed processing, horizontally unlimited scalability, and second is okay. Unlimited data storage is possible because of unlimited scalability. Because observe this. If you're running a business with less number of slaves, for example, with only 3 systems or 10 systems, you're running a small business with 10 systems, S1, S2, so on up to S10. S1, S2, so on up to S10. So your business has increased, your branches have increased, your customers have increased, your data has increased. Similarly, your systems also should keep on increasing horizontally. Horizontally, unlimited scalability. Horizontally, unlimited number of slaves to be added. Horizontally, unlimited number of slaves, right? Yes. Horizontally, unlimited scalability. Very high speed processing because of parallel processing. Because of parallel processing, right? Yes. Very high speed processing because of parallel processing. If you observe parallel and non-parallel, talk about non-parallel and parallel. Non-parallel and parallel. Non-parallel and parallel. For example, one person preparing one item taking 1 minute. The same one person preparing 10 items takes 10 minutes. The same one person preparing 100 items takes 100 minutes. But in the case of parallel processing, one item 1 minute, 10 items also 1 minute, 100 items also 1 minute. Okay. In best parallel pro, one item 1 minute, 10 items 1 minute, 100 items also 1 minute. Okay. Understood. Here we are saying about persons, but in our terminology systems. Here, one, 10 systems, 100 systems running parallelly, 1 minute only. Can handle all varieties of data, structured, unstructured, and semi-structured data. It is an Hadoop is an open source, no licensing is required. Hadoop is an open source, no licensing is required, right? Yes, most of the Hadoop products are from Apache. You can take it from Apache site, Apache mirrors the site. Yes. Commodity hardware. Commodity hardware means Hadoop can run on any hardware. It doesn't mean that you need to have the highly configured systems. It can run on any hardware systems. So these are the Hadoop advantages, right? Unlimited data storage, high speed processing, can handle all varieties of data, structured, unstructured, and semi-structured, right? Open source and commodity hardware. Yahoo, it has taken a table. See, there are many tests done, right? There are many tests done to check the speed of Hadoop as compared with other things, right? Yahoo has conducted a test taking a table of 100 TB consisting of 1024 columns. Task is sorting based on 16 columns. Time taken, right, by Oracle to process this, right? 100 TB data sorting based on 16 columns. It has taken nearly 3.5 days. Teradata, it has taken nearly 4.5 hours, right? Sorry. MySQL has taken 6 days. Oracle 3.5 days, but specialized databases like Teradata, which are used for data warehouse, taken just 4.5 hours. Netija, another specialized database used for data warehouse, used just 3 hours, taken just 3 hours. Finally, Hadoop. Hadoop has taken 3.4 minutes. Hadoop has just taken 3.4 minutes. The latest version of Hadoop has just taken 1.2 minutes. This is the speed of Hadoop as compared with the other things, right? This is the speed of Hadoop as compared with the other databases. Okay, not only processing point of view, Hadoop has proven in the market, storage point of view also, right? You can just also see Hadoop has also proven storage point of view. Here I got a query. Why databases like Oracle won't support unlimited storage? Why databases? Why databases like Hadoop? Why databases like Hadoop? No, no, sorry, databases like Oracle won't support unlimited storage. So if we talk for Oracle in the real time, you can go with multiple systems. Means here databases and the max limit on the number of slaves. Max limit on the number of slave systems. Number of slave systems. First one, databases and max limit on the number of slave systems. Database like Oracle, it can go with a maximum 256 nodes or systems. 256 nodes. Max, beyond that, it cannot support. Even MySQL, right? Maximum it can go with. It can go with only 54. It can go only with 54 systems. And MySQL Express is there. MySQL Express. It can go with the 256 nodes. So, and if you talk about SQL Server, it can go with the maximum 256 nodes. And Oracle, MySQL Express, SQL Server, and DB2. DB2 means 256 nodes. Oracle, MySQL Express, SQL Server, DB2. Okay, all these databases can go with maximum 256 nodes. Beyond that, it cannot support. Even databases like Oracle, for example, even if 256 nodes are used, means just like your mobile phone. If I take a labor example, just like your mobile phone, if it is given 64 GB internal storage, if all the 64 GB, if you have filled it, then the performance of the phone degrades. In the same way here, if all the 256 nodes utilized, the performance of the system degrades. Sometimes it won't even start. And talk about the specialized databases like Teradata. If you go with specialized database like Teradata, it can go with the maximum 512 nodes. 512 nodes. Currently, it is going with 1024, right? 1024 nodes or systems. Next, it is Netija. It is going with 512 nodes, 512 nodes. Yes. Currently, it is going with 1024. 1024 nodes. And Vertica. Also going with 512 nodes. 512 nodes. Yes. So none of these databases are specialized databases are handling unlimited data, not pass. Once this data 1,000 nodes gets filled, they cannot support data further. But there is no limit. But there is no limit on the number of slaves. There is no limit. There is no limit on the number of slaves that Hadoop can have. But there is no limit on the number of slaves that Hadoop can have. No limit on the number of slaves that Hadoop can have. It can go with unlimited number of slaves. Okay. Yahoo when first time implemented Hadoop. Yahoo when first time implemented Hadoop. Went with 4,000 slaves for storing its data. 4,000 nodes for storing its data. Currently, it is going with currently Yahoo going with 12,000 nodes. Facebook when first time implemented Hadoop. Facebook when first time implemented Hadoop. Went with 8,000 nodes for storing its data. Currently Facebook going with it's going with 52,000 nodes for storing its data. So there is no limit on the number of systems that Hadoop can have, right? Unlimited, right? Either 5,000 or 5,000 or 10,000 or 50,000, right? There is no, right? Yes. So Hadoop is proven in the market, storage point of view, processing point of view, with unlimited data storage and very high speed processing. Just now I discussed, right? The speed wise also like whether it has taken days of time and this has taken hours of time, but Hadoop has taken minutes of time. So just I was briefing you, right? Even like what is Spark, PySpark, need for PySpark, a real life usage of PySpark, PySpark job market. This is so Apache Spark is an open source distributed cluster computing framework introduced by Apache Software Foundation. It is a general engine for big data analysis, processing, and computation, right? And why PySpark? It is a Python API to use Spark. PySpark is a Python API to use Spark. So I said it is the cluster computing system which is used for big data solution. It's a lightning fast technology that is designed for fast computation. It is an open source. It is a and PySpark is used for running a distributed SQL. But PySpark used for running creating data pipelines for ingesting data into databases. Also used for running ML algorithms. Also, right, working with graph algorithms for data streams and many and need for PySpark. So huge data is getting generated. So this data contains of hidden patterns, unknown corrections, user preferences, market trends, and other useful information. So you need to extract that valuable information from the raw data. So so we need to have some efficient tools to perform these kind of operations for huge data. So we need some scalable and flexible tools to crack this, right? Data and gain benefit from this. So PySpark is such a kind. So combining a Python and Spark will be the efficient way for the world of big data. That's why Apache Spark community came up with a tool called PySpark, Python plus Spark, Python API for Spark. Real life usage of PySpark that is used in the commercial sector. PySpark is used in the commercial sector, right? Apache Spark, a real-time processing. Banks and other financial fields, they're using Spark, PySpark to retrieve the customer's social media profile and analyzing, gaining insights, which helps in taking the right decisions. And in credit risk assessments and fraud detections, it is used. In healthcare, analyzing the patients and who is going to face that issue based on these records. And even entertainment industry like Netflix using PySpark. The popular OTT platform like Netflix using Spark, right? Real-time processing, personalized online movies or web series. It is going to process nearly 450 billion events per day, streamed over server-side applications. And also like e-commerce websites like Flipkart, Amazon, all these Apaches, Amazon, Flipkart are using Apache Spark for advertising and to enhance the customer experience, right? Even in the tourism industry to advise millions of customers in this way. Today, PySpark is mostly used and even PySpark has got great demand. You see the job market for it, right? Because of its very high speed, huge data processing at a very quick rate of speed. If you see in the previously, I have shown one example. PySpark, very high speed technology, right? And if you see the salary package for this also like 2 times more than the other technologies or 1.5 times more than the other technologies, you can compare that salary packages, right? In the same way, they'll be expecting the skills from you, the technical skills of this PySpark. So everything will be discussing from the ground level to advanced level with many working examples. You see that course content for it. So this is the course content. Big data Hadoop. What is big data? Need for Hadoop RDBMS, advantage of Hadoop, Hadoop ecosystem components, HDFS, Hadoop distributed file system, and map reduce, entire map reduce in brief. Scoop, SQL plus Hadoop. The first two characters and the last three characters, SQL plus Hadoop for import and export operations. Exporting from HBase to, okay, importing and exporting, and also transformations, filtering and grouping, mergings, right? Yet another resource negotiator and speculative execution, speculative job, and speculative task. Yarn components, yarn architecture, how the processing is happening. And I'll be discussing one NoSQL database also. So three processing components I'll be discussing. One storage component like HDFS, one NoSQL database like HBase, and one streaming component like Kafka I'll be discussing as part of this course, right? And a NoSQL database like HBase, Hadoop's database, and how to perform CRUD operations, creating tables, reading, inserting, update, delete, and integrations with Hive and its architecture. Hive, one of the important component of Hadoop, only you can see jobs in Hive, right? You can see a lot of jobs for only in Hive component. In Hadoop, Hive is there. You can see just type Hive jobs, you say. Just say Hive jobs. You can see a lot of jobs. 11,490 Hive job vacancies in December 2024. Hive 11,490. Only on Hive, if you know that knowledge on this Hive, right? Yes. Carry rate Hive, right? Yes. Big data, Hadoop and Hive. Big data engineer, right? Big data, Hive, Spark, Scoop, right? This one. A big data, Hadoop, right? Yes, lot of jobs for this. And coming back to this, so only with that way we'll be discussing in brief about Hive architecture. It's metastore. It's like just like SQL. HQL is there. HQL Hive query language. Difference between HQL and SQL. 90% they are same, but 10% you see where it can handle unstructured, semi-structured data. Built-in functions, you can see loading data from files, Hive tables from HDFS files, internal tables, external tables, working with unstructured, working with XML data, Hive working with JSON data, URL weblog data, unions, UDF, UDAF, UDTFs, partition table, performance tuning mechanism, partitioning, indexing, bucketing, and indexing in Hive, right? And coming to the PySpark. PySpark, very high-speed processing, which has great boom today. In this, right, PySpark introduction, need for PySpark RTD computations, persistence options, PySpark core computing, groupings and aggregations, single grouping, multi-grouping, multiple aggregations, various actions and transformations, union, distinct, sort by key, count by value, count by key, PySpark SQL data frame API. So creating data frame, empty data frame, struct type, struct field, row class, column class, select, collect with column, where, filter, draw. All these are the built-in functions with many working examples. PySpark SQL functions, aggregate functions, PySpark built-in functions, all these external sources. Deployment modes, PySpark applications, stage and task, driver and executor, building Spark applications. So PySpark streaming concept, integration with Kafka and MLA. Apart from this, even Python, you need to have some knowledge on this. So Python basics, Python operations, operators, IDs in Python, flow control statements, looping statements, strings, collections, lists, tuples, sets, dictionaries, functions in Python, and modules in Python, modular programming, packages in Python, errors and exceptions in Python, file handling, object-oriented programming concepts, regular expressions, how to extract required data from the given data, database connectivity, how to connect with the database, I'll show you the installation of one database, Python datetime, operating system related, iterators, generators, closers, decorators, web scraping, graphic module like Excel, working with Excel, data analytics, connection to data science, Python pandas module in brief, NumPy numerical Python in brief, Matplotlib for plotting visualizations, generating graphs. So all this in brief, right? Yes. So I was just saying, so in this course, you'll be learning mainly for technologies like Hadoop, PySpark, Linux, and Python. So Python, nearly 50 sessions you'll be having. Just now I showed you, right, how briefly. So both Python core and advanced will be discussed. Monday to Friday, you'll have class for this Python. You can attend any of my Python batch. So tomorrow, Monday at 8 o'clock, there is a Python batch. And this coming Thursday, if you want evening batch, there is 8 p.m. There is a Python batch going to start. Monday, tomorrow is at 8 a.m. And these three things will be on Saturdays and Sundays. 2 hours on Saturday and 2 hours on Sunday. It goes for 12 weekends. In brief, 15,000 is the course fee for all this, right? Yes. Any queries from your side? No. So as I said, said by the Durga software, you can see a big message in the Zoom chart. A big message is given in the Zoom chart, right? Link will be changing. So the link will be changing for next Saturday. So you are supposed to get enrolled for getting this link. So from next Saturday, we'll be starting with the things. I'll be demonstrating about the softwares, other things, right? So get enrolled. You'll be getting the videos to your Google Drive. Notes, soft copy of the notes, clear soft copy of the notes will be provided. A WhatsApp group for technical discussions, or if you get any errors, you can take snap of it and post in the group. Interview questions, assignments and tasks to work with, right? All this. So you'll be getting the videos to your Google Drive, notes to your mail address, and you'll be added next Saturday, you'll be added to the WhatsApp groups. Every day, every session videos you'll be getting. If you miss any sessions, you can go through that videos and check, right? and attend the next session for the better understanding. Any queries from your side, right? Any queries from your side, anyone?
Hello.
Yes, go ahead.
Yes. Regarding the practical and labs, what type of preparation need to be from our side? Like what type of device or machine need to be prepared for this? Or there will
So,
be remote access lab?
so for the practicals, right? I'll be providing you like a FIGB soft, like you need to download. I'll be forwarding to your Google Drive, and I'll be just guiding you. I'll be demonstrating you how to work with it, how to use it. No need of any, so just whatever system you have got, that's fine. So
Okay.
basics of SQL required, and Linux anyhow I'll be discussing, and Python also will be discussed. So that's other prerequisites, right? Linux as basic SQL and Python are the prerequisites. Anyhow, Python and Linux I'll be discussing, and basic SQL also wherever required I'll be just demonstrating, right? So
Mm.
don't worry
Oh,
about the software. Just I'll be providing you the things.
no, I
You
mean for the hardware itself, is there a specific requirement for the laptops or
So
something to
if
be?
RAM like minimum 8 GB, if it is fine, if it is there, it's fine. Remaining every nothing, right? If you have got a good
Okay.
RAM, okay. If you have got a minimum 8 GB RAM required, if you have got less than that also, but the only thing is the speed will be less.
Okay.
Whenever
Okay.
you type
Fine.
any command, very fast or very slow, you are getting the response. Depends upon your RAM capacity.
Okay.
What is
And
your RAM?
how long the session is going to be for the next weeks? Because here I'm asking because for me Sunday is not the working day.
So next week,
I
right?
just
Saturday, so five to seven, right?
five to
Five to,
seven.
5 to 7, right? 2 hours and 2 hours on Saturday, 2 hours
Wow.
on Sunday. And this Python, whatever you are attending, either you can choose morning batch or evening batch for Python.
Okay.
It will be from
Mm.
Monday to Friday. It will be Python sessions. You need to attend this either weekdays from Monday to Friday, morning or evening, or going through the videos of it. And this will be in the weekends, 2 hours on Saturday, 2 hours on Sunday. Sometimes we'll be extending when we start with the practicals. Right?
And for the Python as well, there will be recordings, correct?
So
You
all
can,
these are live sessions. All these are live sessions.
I mean, yes, but because I'm just joining from different time zone and different even weekend days, weekdays and weekend days. That's why I'm asking mainly about if I miss any session, there will be recording even for Linux or for Python or for every part of this
Everything
training,
for
correct?
all these things, you'll be getting the recordings, right? Immediately
Okay,
if the session completes, the session recording you'll be getting, right?
great. Thank
For
you.
all this. Okay,
Thanks.
fine. Okay. So if I'm done with your queries, then I'm signing off for now. Meet you on next Saturday, starting with this Hadoop, right? When Hadoop is going, right, we will be learning Python in the weekdays. So by the time this Hadoop completes, this Python core gets completed. When we start with PySpark, Python Advanced will be started. Both will be running parallel. Right? Before that, before I start with this, right, I'll be also demonstrating about the Linux commands. Right? Fine. Okay. Thank you all for your time. Thank you. Meet you on next Saturday. Get enrolled for getting all these things, videos, notes, and getting added to the WhatsApp. Right? Yes. Thank you all. Bye. Yeah. 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 Good evening, all. So myself, I'm like I hold 20 plus years of experience, which includes nearly 10 plus years of experience in Hadoop and Spark environment. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not, right? Okay. So as part of today, I'll be yes. Thank you. Yeah. As part of today's exam, I'll be covering the following things. So what is big data? What is a big data? Why Hadoop? Why Hadoop? Drawbacks with the current databases. Drawbacks with the current databases. Drawbacks with the current databases. Hadoop and Spark. Hadoop and PySpark. Advantages. Hadoop and PySpark. Job market. So yes, starting with big data. The name itself saying like huge volumes of data. Currently, the data is getting stored. How the data storage units like KBs of data, MBs of data, GBs of data, gigabytes, terabytes. Beyond that, we have got petabytes, exabytes, zettabytes, etabytes, sotabytes, so on. KBs of data, MBs of data, GBs, TBs, petabytes, exabytes, etabytes, sotabytes, right? You should have seen KBs of data, MBs of data, GBs of data, even TBs of data. But beyond that, today data is getting generated in petabytes, right? 1 petabyte equal to 1 petabyte equal to 1024 TBs. Already 1 TB is a large storage unit. Examples of petabytes of data generation. Examples of petabytes of data generation. Take example of a banking sector. If you take example of a SBI bank, within the city we see hundreds of branches for SBI. Within the entire state we see thousands of branches for SBI. Within the entire country, lakhs of branches for SBI, right? Again, with each branch, millions and millions of customers. Each customer making multiple transactions per hour, per day, per week, per month, and year. Each and every transaction has to be stored, right? Huge data is getting generated. Forget about this. You are aware about social media like Facebook. For Facebook, millions and trillions of users. Not only within the country, entire world. In a minute, how many posts and videos are getting circulated? It has to store each and every post and video, right? What is the data generated by Facebook in a minute, in a hour, in a day, in a week? So huge data is getting generated, right? Not only like Facebook, today, most of the applications are generating data in petabytes. Talk about any application, for example, if I take 1 minute transaction, how many Facebook posts? What is the data generated by Facebook in a minute? What is the data generated by Twitter in a minute? Keeps on generating, right? And what is the data generated by Google? Google queries. Today, everyone are querying in the Google, right? What is the data generated by Google in 1 minute? And everyone, you are uploading the videos in the YouTube. YouTube videos upload. What should be the storage capacity to store all the videos? and millions and trillions of users, email messages, millions and trillions of messages need to be stored, right? And just now I was talking about bank transactions, or if we talk about the telecom transactions, huge data, telecom transactions, or if I talk about e-commerce transactions, like Flipkart, Amazon transactions, huge data is getting generated everywhere. Huge data is getting generated everywhere, right? Yes. So everywhere, huge data is getting generated. And for storing this huge data means in petabytes, right? So if you talk currently we have got databases. Currently we have got databases like Oracle, MySQL, DB2, SQL Server, right? All this they are used for OLTP, online transactional processing. All this they are used for what? Online transactional processing for day-to-day operations. But we have got some specialized databases. We have got some specialized databases used for data warehouse purpose like Netija. We have got some specialized databases like Netija, Vertica, Teradata. These are used for data warehouse purpose, right? These are used for data warehouse. These databases are specialized databases. They can handle data up to some extent. They can handle data up to some extent, but beyond that, so for storing unlimited data storage, databases and specialized databases cannot handle unlimited storage, cannot store unlimited data. So as a solution to this storage level problems and processing level problems, we have got a framework called Hadoop. So before I go with the Hadoop, you need to know about the data, how the data is getting generated, how the data is getting generated, right? This is the data which has been generated from the last 50 years. Nineteen 74 to, okay. Observe this. 2014 to 2024. See the last, observe this last 10 days, 10 years, sorry, with the previous 40 years. 20% of the data, what we are seeing in the current, see 80% of the data, what we are seeing currently has been generated from last 10 to 15 years. And previous 40 years, only 20% of the data is getting generated. Reasons for the huge data generation, especially from the last 10 years, because of usage of technology, because of usage of smartphones, because of usage of internet, because of usage of technology, usage of smartphones, usage of internet, right? Huge data is getting generated, especially from the last 10 to 15 years. And the main sources from where this data is getting generated, mainly three sources of data. Mainly three sources of data. Social data, machine data, transactional data, social data, social data, machine data, and transactional data. Data which has been generated from social websites, right? Like Facebook, Twitter, WhatsApp, all this we call such data as social data. Machine data, data which has been generated by reading or scanning the barcodes or RFID chips. Such kind of data we call as machine data. And transactional data, data which has been generated from day-to-day transactions like bank transactions, telecom transactions. Yes. And this is going to occupy three formats, three types of data. You can see like three types of data. Three types of data, right? Structured data. Yes, structured data, semi-structured and unstructured. Unstructured data. Structured data, data which is organized in the form of structured manner in the form of rows and columns, like database tables, DB tables, Excel sheets. Semi-structured data means data which is not fully structured, which is not fully unstructured, like JSON files. Unstructured data. Unstructured data like raw text, short messages. So this semi-structured means XML, JSON all comes as semi-structured. Short messages, raw text, images, videos, right? So the biggest challenge is today like handling this unstructured data. So databases can handle only structured data, but the biggest challenge to handle all varieties, structured, semi-structured, and structured. So Hadoop can handle all varieties of data, structured, semi-structured, and unstructured data. So day by day, as data is increasing enormously, as we need to have some proper storage systems, right, for storing and for processing it. So Hadoop, we have got a framework like Hadoop. So to handle as a solution to all the storage level problems and processing level problems, we have got a framework like Hadoop. Hadoop is mainly meant for two things, for storage and for processing. It is meant for storage and it is meant for processing. It is meant for storage, it's meant for processing. For storage we are using HD. So okay, it is performing storage and processing. How to performs both storage and processing? If you talk, any technology performs either storage or processing. For example, C or C++ or Java or .NET. All this, they are meant for processing. They are meant for processing. And if we talk like Oracle, MySQL, SQL Server, all this they are meant for storage. So any technology performs either storage or processing, but Hadoop performs both storage and processing. So for storage, does Hadoop use any databases internally for storing its data? No. It is going with Hadoop distributed file system, and for processing, it is going with an execution model called as MapReduce. It is going with an execution model called as MapReduce. For storage, HDFS, and for processing, MapReduce. Or currently we are going with Spark, MapReduce Spark. Okay. So you need to clearly understand. So when Hadoop is able to perform both storage and processing, what is the necessity of the current processing and storage technologies? When Hadoop is performing both storage and processing, what is the use of this means? You need to clearly understand Hadoop is for batch applications. Hadoop is for batch processing, for millions and trillions of records. For a single transaction, Hadoop is not required. If you are making a single transaction happen, go for databases only. Hadoop is good for huge data. Hadoop is good for huge data. Hadoop is bad for small data, right? And you may get a query, why databases like Oracle? So what is the drawback with the databases? Drawbacks with the current databases. Drawbacks with the current databases. Drawbacks with the current databases. First thing is most of the databases limited storage. Most of the databases limited storage. And secondly, most of the databases with a limited storage. Yes. And no parallel processing in most of the databases, no parallel processing. Most of the databases, no parallel processing. And limited storage, no parallel processing. And next, see here, as volume increases, volume of the data increases, speed decreases, volume increases, speed decreases here. For example, observe this query, select total amount, right? From sales one, total amount from sales one, which has got 10 records. Select the total amount. Select total amount from sales two. From sales two, which has got 1 lakh, which has got 10 lakh records. Select the total amount from sales three. Total amount from sales three. Observe. Here it has got 10 crore. It has got 10 crore records. From query to query, as the volume increasing, right? Query to query, volume increasing. So which query is going to execute faster among these three? Obviously, the first query with 10 records, right? Total amount of 10 records as compared with 10 lakh and 10 crore. So query to query, as the volume increasing, speed decreasing, right? Speed decreases, right? Hmm. Next, if complexity increases, if complexity increases, if complexity increases, right? Speed decreases, right? Yes, one second. If complexity increases, speed decreases. For example, observe this query. Same thing I'm taking, right? Total, let's select total amount from sales one. Assume it has got 1 lakh records. The same way, select average of average amount. Sales one only. Select average amount from sales one. Okay, same 1 lakh records only. Same table, right? Select the standard deviation, right? Standard deviation of amount. Standard deviation of amount from sales one. Same thing. So which query is going to execute faster among these three? Which query is going to execute faster among these three means obviously again the first query, because the average amount is a two-step process. First sum to be calculated, next average to be calculated, as compared to the first query. Second query is a time taking, right? And standard deviation of amount, a lot of internal processing is required. So query to query, even if the complexity increasing, speed decreasing, right? Yes. Databases can handle only structured data. Databases can handle only structured data. They cannot handle unstructured, semi-structured data. For example, just check with this. If I want to take reviews for a particular movie, reviews, a table, we have got a table, user and the review, user giving review. If the movie is good, for example, user 1, user 2, user 3, in this way 100 users are there. If the movie is good, saying 1. If the movie is bad, saying 0. If the movie is good, saying 1. Saying 0, saying in the form of zeros and ones, right? So they are giving, okay, user 1, user 2, user 3. So 100 users, they are giving in the form of zeros and ones. Can you write an SQL query to count the number of ones and zeros? Can you write an SQL query to see the number of ones and zeros, right? How many ones and how many zeros means how many goods and not goods. Yes. Select review wise count. Review wise count I want. Review wise count from a reviews table. Group by review. Group by review. Select review wise count from reviews group by observe this output 1 and 0 review wise. The count 90 people saying the movie good, 10 people saying the movie bad. Okay, but generally reviews won't be given in the form of zeros and ones. They'll be given in their own text format. First person saying movie is good. Second person saying movie is not good. So in this way, in the own text format, they're given in their own text format. Movie is good, movie is not good, right? In this way, they have given. Can you write an SQL query now saying how many goods and how many not goods? We cannot write a query, right? Now we cannot, databases cannot handle this kind of data. Even by using keyword counter, it gives wrong computation because even not good has got good in it. So databases can handle only structured data. They cannot handle unstructured or semi-structured data. Hadoop advantages. First one, unlimited data storage. Unlimited data storage. Unlimited data storage is possible, right? Unlimited data storage. Unlimited data storage. Second thing is like very high speed processing. Very high speed processing. Unlimited data storage, very high speed processing. Can handle all varieties of data. Can handle all varieties of data. Fourth, it's an open source. It is an open source. No licensing is required. Unlimited data storage, very high speed processing, can handle all varieties of data. Open source. Commodity hardware. Commodity hardware. Unlimited data storage, very high speed processing, can handle all varieties of data. It's an open source. Commodity hardware, right? Okay. Commodity hardware means it can run on any hardware. Doesn't mean that you need to have the latest configuration. There's an open source. Most of these Hadoop products are from Apache. It can take from Apache major site. No licensing required. Can handle all varieties of data, structured, unstructured, and semi-structured. Very high speed processing because of parallel processing. Unlimited data storage. Huge data can be stored. Unlimited. Hadoop is proven in the market, storage point of view and processing point of view. Okay. There are many tests were conducted, right? For example, Yahoo has conducted a test. Yahoo has conducted a test. Yahoo has taken a table of 100 TB. consisting of 1024 columns. 1024 columns. The task sorting based on 16 columns, sorting based on 16 columns. So time taken by different databases. Time taken by different databases. Oracle. Oracle has taken nearly 3.5 days to process this. MySQL. MySQL. MySQL has taken nearly 6 days. Teradata. Teradata, right? Specialized database used for data warehouse purpose. It has just taken 4.5 hours. One more specialized database used for data warehouse. Netija. It has just taken 3 hours. And finally, Hadoop has taken just 3.4 minutes. 3.4 minutes. The latest version of Hadoop just taken 1.2 minutes. So this is what the Hadoop speed has compared with the other databases. Whether these have taken days of time, have taken hours of time, these have taken minutes of time, right? 100 TBs of data, right? So Hadoop is proven in the market, processing point of view, and even storage point of view, right? Yes. And even Spark, even if we talk about Spark, very high speed processing, right? So just I'll give some overview about Spark, just 5-10 minutes I take. What is Apache Spark? Why PySpark? Why PySpark? Need for PySpark? Need for PySpark? Real life usage? Real life usage of PySpark? PySpark job market. What is Apache Spark? Why PySpark? Need for PySpark? Real life usage of PySpark? PySpark job market. Okay. So Apache Spark, it is an open source distributed cluster computing framework introduced by Apache Software Foundation. It is a general engine for big data analysis, processing, and computation, right? Why PySpark? It is a Python API to use Spark. Python API to use Spark. It's an open source cluster computing system used for big data solutions. PySpark is the lightning fast technology that is designed for fast computation. It is one of the demanding tool among the data engineers to work with bigger data sets. It is running distributed it's used for running distributed SQL, for creating a data pipelines, ingesting data into databases, for machine learning algorithms, working with the graphs and working with the data streams, right? Need for PySpark, if we talk huge amount of data, is getting generated both through offline and through online. This data contains hidden patterns, unknown corrections, market trend, user preferences, and other useful information. It is necessary that we need to extract valuable information from the raw data. So we require some efficient tools to perform different types of operations on this huge data. But there are various tools to perform multiple tasks on this huge data. But we doesn't have, okay, these tools are not so appealing. So we need to have some flexible and scalable, right, tools to crack a big data and gain benefits from it. So PySpark is such a kind. PySpark is such a kind, right? So the combination of Python and Spark. So combination of Python and Spark would be the very efficient way for the world of big data. So that's why Apache Spark community came up with a tool. It has come up with a tool called PySpark. It came up with a tool called PySpark, that is Python API for Apache Spark. Okay. And if we talk about the real life use cases, right, used in the commercial sector, like Apache Spark real-time processing systems, banks and other financial fields, they're using Spark to retrieve the customer's social media profile and analyze to gain useful insights, which can help to take the right decisions. The extracted information is used for credit risk assessment, targeted ads, and customer segmentation. Spark plays a significant role in fraud detection and in healthcare systems to analyze the patient's records and analyzing and identifying which patient is going to face the issue. And even in the entertainment industry, right? A popular OTT platform, Netflix, using Apache Spark. It is using Apache Spark for real-time processing, personalized online movies and web series, right? So it processes nearly 450 billion events per day that are streamed over server-side applications. And even for trading and e-commerce, right? Websites like Flipkart, Amazon, all these they are using Apache Spark for advertising. And for tourism industry also, advising millions of travelers by comparing hundreds of tourism sites. Okay. PySpark job market. PySpark job market. So if you see the job market, right, PySpark job market, a lot of jobs for this PySpark. It has got a great demand, and you can see like huge salary packages for this PySpark especially. And the same way they'll be expecting the skills from you, right? Yes. Fine. You can just Google and check PySpark jobs and Hadoop jobs, right? A lot of jobs for that. You can see the course content, right? What I'm going to discuss as part of this. Big data Hadoop. What is big data? Why Hadoop? Drawbacks of these databases, sources and types of data, comparison with other technologies, RDBMS and Hadoop, advantages of Hadoop, Hadoop ecosystem components, HDFS, the first thing, right? Hadoop distributed file system, features of HDFS, name node, data node, blocks, configuring block size, HDFS architecture, name node, data node, secondary name node, job tracker, task tracker, yes, map reduce architecture, processing domains, and this scoop for import and export operations, SQL and Hadoop. Uh, for importing data from databases to Hadoop and exporting data from Hadoop to databases for import export operations we use. Yarn. Yet another. So during this import export operations, you can perform different operations, transformations, filterings, mergings, sortings. Yarn. Yet another resource negotiator. What is speculative execution, speculative job, speculative task, comparison with the previous versions, yarn components, resource map, different components, right? How the processing is going to happen within this yarn, and NoSQL database. What is NoSQL? NoSQL problems with RDBMS, types of NoSQL databases, different types of NoSQL in that one NoSQL database, that is HBase, Hadoop's database, right? And here we are going to discuss the how to create CUDA operations, HBase use cases, their column families, HBase architecture, HBase data modeling, HBase CUDA operations, Hive and HBase integration, Hive, Hive introduction, Hive architecture, Hive metastore, Hive query language, differences between HQL and SQL, Hive built-in functions, loading data from local files to Hive tables, loading data from HDFS files to Hive tables, inner tables, external tables, Hive working with unstructured data, Hive working with unstructured data, Hive working with XML data, Hive working with JSON data, Hive working with URLs and weblog data, Hive unions, Hive joins, inserting into local files, inserting into HDFS files, Hive UDF, Hive UDAF, Hive user-defined function, Hive user-defined aggregated functions, Hive UDF, user-defined functions, user-defined aggregated functions, user-defined tabular functions. UDF, UDAF, UDTF, user-defined functions, user-defined aggregated functions, user-defined tabular functions, partition table, non-partition tables, multi-column partitioning, right? Partitioned tables, non-partitioned tables, multi-column partitioning, dynamic partitions, performance tuning mechanism, right? Yes. And bucketing in Hive, indexing in Hive, right? Performance tuning mechanisms in Hive. And so I'm going to discuss one storage component here, three processing components, MapReduce, Hive, and PySpark, and one NoSQL database, and also one streaming technology, right? Like Kafka will be discussed. PySpark introduction, why PySpark, need for PySpark, PySpark session, PySpark context, and PySpark RTD computations, operations on RTD, persistence options, PySpark core computations, groupings and aggregations, single grouping, multi-grouping, single aggregations, multiple aggregations, various actions and transformations, count by key, count by value, sort by key, union distincts, various count aggregations, PySpark SQL data frame, SQL API, data frame API, how to create a data frame API, and PySpark creating a data frame, creating an empty data frame, convert RTD to data frame, convert data frame to pandas, PySpark show, struct type and struct field, row class, column class, select, collect, with column renamed, variant filter, drop and drop duplicates, order by and sort, group by, John, union by name, UDF, map, flat map for each sample, pivot, partition by array type, map type, PySpark SQL functions, PySpark aggregate functions, window functions, data and timestamp functions, JSON functions, reading and writing JSON file, PySpark built-in functions, when expr, lit, split, substring, translate, overlay, to timestamp, to date, months between, explode, array, collect, set, map keys, map values, struct. So many built-in functions with many working examples. PySpark external sources working with SQL statements. Spark and Hive integration, Spark and MySQL working with CSV, working with JSON transformations actions, narrow and wide transformations, adding of new rows, dropping rows, handling nulls, deployment modes, local mode, cluster mode, PySpark applications, stays and tasks, drivers and executors, and building applications, pipelines, deploying Spark apps, performance tuning, PySpark streaming concepts, PySpark streaming, right? And the integration with Kafka and PySpark ML. And also for this PySpark, you require Python, right? Total coding goes in Python, total implementation in Python. Even Python, both core and advanced, both are discussed. What is Python? Why Python? Applications, features, versions, Python operations, modes, interactive mode, batch mode, various editors and IDEs, integrated development environments, constants, data types, variables, comments, escape sequences, strings in Python, right? And operators in Python, Python IDEs, Anaconda, Prompt Anaconda Navigator, Jupyter Notebook, Spider, Eclipse, VS Code, flow control statements, looping statements, strings in Python, string indexing, string slicing, string functions, string methods, string special characters, collections, list tuple sets, dictionaries, Python lists, list operations, list indexing, list slicing, list functions, list methods, list addresses, tuples, sets, dictionaries, functions in Python, modules, modular programming, renaming a model, reloading a model, normal import from import, packages in Python, errors and exceptions, file handling in Python, object-oriented programming concepts, regular expression module, extracting data from the given data, database connectivity, installation of database, Python data and time, operating system module, and advanced concepts like iterators, generators, closers, decorators, working with CSV, XML, JSON, graphic programming, and Excel workbook, data analytics, introduction to this data science, Pandas model in brief, NumPy model in brief, and Matplotlib model in brief. So this is what I'll be discussing, right? Yes. So here mainly four things: Hadoop, PySpark, Linux, and Python total core and advanced, right? This Python nearly like 50 sessions will be there on this. You can attend. For this, you will be attending regular sessions, right? From Monday to Friday. So, so here, Monday at 8 a.m. there is one session, one Python batch. You can attend this. Means Python you need to attend separately because it is time taking. Or Thursday there is a batch at 8 p.m. This the coming Thursday. IST timings, right? 8 a.m. if you want morning or evening, right? And this Hadoop, PySpark, and Linux, it goes for nearly 12 weekends. 12 weekends, right? Saturday 2 hours, Sunday 2 hours. All right. 5 to 7. 5 to 7 it will be right. And the fee structure is 15,000 for this. In brief, in depth, we will be discussing all this. 15,000 for this, right? Any queries from your side? Tomorrow also you can attend the session at 5 o'clock. Same time, using the same link to see more discussion on this, right? Yes. Any queries from your side?
Sir, will you continue this batch because we have very less strength, right?
Hello? Yeah, no, it will be continued.
Because only 2 members joined, right? That's why I have that doubt.
No. Some other students also are available who are attending Python. They are looking for big data to start. They are attending
Okay.
already Python sessions who have got enrolled for these packages.
Okay.
They already
Okay.
attended this demo, Hadoop demo, but they are attending for the regular sessions to start.
Okay, sir. Thank you.
Fine. So tomorrow also you can attend to see more discussion on this same time at 5 p.m. using the same link, right? Yes. Fine.
Okay, sir. Thank you.
Yeah. So in the last class, just we had an introductory session, right? What is big data and why Hadoop drawbacks with the current databases. Yes, big data like huge volumes of data. So currently we have got databases for storing the data like Oracle, MySQL, DB2, SQL Server, and we have got some specialized, just I'll take 2 minutes what we have discussed in the last session. Specialized databases like Netezza, Vertica, and Teradata used for data warehouse purpose. But these databases and specialized databases, they can handle data up to some certain extent, right? Beyond that, they cannot support, right? So we have got, so as a solution to all the storage level problems and processing level problems, we have got a framework like Hadoop. Hadoop is mainly meant for two things. Generally, any technology used either for storage or for processing. They're used either for storage or processing, but Hadoop is used for both storage and processing. Yes. Meant for storage, and second meant for processing. It is meant for both storage and processing. Hadoop is meant for both storing data and processing data. We talk about like C, C++, Java, .NET, all meant for processing. Oracle, MySQL, DB2, SQL Server, all meant for storage. But Hadoop performs both storage and processing. For storage, it doesn't use any databases because databases has got a lot of drawbacks as compared with this, right? So Hadoop is going with a special kind of file system. It's going with a special kind of file system called as Hadoop distributed file system. And for processing, it is not going with any, for processing, it is not going with any current technology, right? Yes. It is going with an execution model called as MapReduce, and currently we are using Spark. Spark, very high speed processing technology, processing huge data in quick time. All right, yes. So for storage HDFS and for processing MapReduce or Spark. Yes, drawbacks with the current databases, right? Limit. Okay. So if it, before I go with the drawbacks with the databases, you may ask why if Hadoop is there for storing and processing, what is the use of the current processing technologies and storage technologies? Already Hadoop can perform both storage and processing. Why again this storage and processing technologies? You need to clearly understand, right? Hadoop is for batch applications. Hadoop is for batch applications. Sorry. Hadoop is meant for batch application. Hadoop is meant for batch applications. Hadoop is meant for batch applications. So there are two types of application. What do you mean by batch application? There are two types of applications. There are two types of applications. The first one, online applications. Second is like batch applications. So what is the difference between these two? Online applications and batch applications. Hadoop is not for online applications. Hadoop is meant for batch applications. Online applications, user interactive applications, user interactive applications. User interactive applications. Here user gives the input. User interactive applications, here user gives the input. User gives the input. Example, booking a movie ticket. Booking a movie ticket. Making an online transaction. Making an online transaction. Booking a movie ticket, making an online transaction, right? So here compulsory, yeah, the user need to use the input, the source account and destination account. User has to provide that how much amount to be forwarded and what is the source account, what is the destination account. User interacts. But batch application, user non-interactive applications. User non-interactive applications. User non-interactive applications, right? So Hadoop is meant for this user non-interactive applications. Here, user is nowhere required. User is nowhere required. User is nowhere required. Here, example, railway ticketing PNR status. Railway ticketing PNR status, currently our status is 200. After 1 hour, it is 150. Tomorrow morning, it is 100. Tomorrow evening, it got confirmed. Tomorrow evening, it got confirmed, right? Yes. Railway ticketing PNR status. So this is happening. And here, user is nowhere required. Here, everything happening in the background. Most of these banking applications and financial applications are batch applications. And also like generating credit card statements for millions of customers. Credit card statements for millions of customers. For millions of customers. Generating credit card statements for millions of customers. Railway ticketing PNR status. That's generating credit card statements for millions of customers. Okay. So understood, right? Online applications, batch applications. Hadoop is meant for batch application, not for online applications. So batch applications, user non-interactive applications. And here, drawbacks with the current databases. Why databases are not used for storing Hadoop's data? Drawbacks with the current databases. First thing is limited storage. Most of the databases very less storage, right? Limited storage or less storage. No parallel processing in most of the databases. No parallel processing in most of the databases. And as volume increasing, speed decreases. Here, to see that queries, right? For example, total amount from sales 10 records. Total amount from sales to 10 lakh records. Total amount from sales to 10 crore records. Here, as volume increasing from query to query, as the volume increasing, speed decreasing, right? The same way, if complexity increasing, also speed is decreasing here. Total amount from sales 1 lakh records. Average amount from sales 1 lakh records. Standard deviation of amount 1 lakh records. But here, query to query, which query executes faster? Again, the first query. Second query is a two-step process. First sum, next average to be calculated. Complexity increases, speed decreases. If complexity increases, speed decreases. So here average amount is a two-step process as compared with the first query. Second step takes a lot of time, right? And select standard deviation of amount from sales one. So standard deviation of amount from sales one means as compared to the first query and second query, the third query standard deviation takes a lot of internal processing. It takes a lot of internal processing, right? Databases can handle only structured data. They can handle only structured data. They cannot handle unstructured or semi-structured data. They can handle databases can handle only structured data. They cannot handle unstructured or semi-structured data. Yes, these are the major drawbacks, right? Yes. Limited storage, no parallel processing. As volume increases, as speed decreases. Total amount from sales one, total amount from sales two, total amount from sales three. Here 10 records, here 10 lakh records, 10 crore records, right? So volume increases, speed decreasing. Complexity increases, speed decreases, can handle only structured data. And coming to the Hadoop advantages. Yes, before I go to the Hadoop advantages, you need to know something about the Hadoop architecture. Hadoop doesn't follow client server architecture. It won't follow client server architecture. It won't follow client server architecture. It won't follow request response architecture. If you are giving request, giving response, that kind of architecture is not for Hadoop. Hadoop follows master slave architecture. Hadoop follows master slave architecture.